How's it going, Plant Animal Science? This is another episode of Hear It from Schmitt. This is Soil Edition. I'm gonna go through these slides as if I was going through them in class. Some of these things that you will be in those questions that are in your hyperdoc. So fill those out as we go. First thing, did you know? Soil is formed when underlying parent rock breaks down over time. So this is something that happens during any weathering. And when you think of weathering, what is that key word in there? Weather. So it's any rain, sleet, snow, wind, anything like that has to do with weather. Anything that causes erosion, rains, floods, thunderstorms. Hurricanes we don't really see here in California, in Southern California. Tornadoes we don't really get either. But all those things cause rock to break down over time, and then it creates soil. And so all those things contribute to creating what we have as soil. So plant roots also help breaking down the rock. Roots are actually very strong, a plant root, and they can actually break apart rocks into smaller pieces, which then becomes part of the new soil. So I love this image. This image shows these are soils from all over the world, and you can see how not one soil is the same. And so we're going to be learning about what makes up soil and those different, think of it like ingredients into soil. But I just love this rainbow of soil images that I have here. So soil science is a thing. It is actually a career that is very important in the agriculture industry, not only in ag and in building houses and industrial buildings. Soil science is something that is very prestigious, and it's actually a job that is very good paying as well. Soil scientists study the chemical, physical, biological, and mineralogical composition of soils as they relate to plant growth, and they also study the responses of soil types like as fertilizers and tillage practices and crop rotations. Tillage practices how we work the soil in agriculture using those different tractor implements or those different tools in agriculture. So soil equals life. There is tons of life in one small amount of soil. So there's about 70,000 different types of soil in the United States. And so that's not even the world. That's just the United States. When you take 1 gram of soil, there is about 5,000 different types of bacteria in just that 1 gram of soil. And so you take a tablespoon of soil, it has more organisms in that tablespoon than there are people on Earth. So it just shows you there is so much living in soil that we can't even see with the naked eye. And it's pretty incredible what it does for the plants. So characteristics of soil. So soil is a loose mixture of rock fragments, organic material. We kind of already learned, what is organic material. Organic material is that stuff that has died and decomposed over time. So it's leaf, dead roots or dead plants, but that also means animals too. Anything that dies and decomposes in nature and over time breaks down, and it turns into material that plants can use to grow and support itself. So supporting the growth of vegetation. Depending on rock from which the soil was weathered, the original rock that soil came from is called bedrock or parent rock. So that rock that it breaks down over time is called bedrock or parent rock. So one thing though I want to say is when we're talking about soil, I do not want to hear dirt. Dirt is dead. There is nothing living in dirt. It's that dusty stuff that's nothing grows in. Soil is rich and living, and so from now on I want to hear soil, not dirt. So there are materials in soil. So there's rock material. So there's 3 different types that we're going to focus on. There's sand, silt, and clay. The amount of each in the soil sample depends on that initial bedrock that it came from. So they have clay materials, which is the smallest material. Then we have silt, which is the medium material, and then sand, which is the largest material. So you can see in this image here, you can see the particle size, or the size of the texture almost. There's sand is going to be that large particle, silt is going to be that medium, and then clay is itty bitty. Now, soils are categorized by how much, or the percentage of sand, silt, and clay. So those 3 things make up soil. So these are called soil textures. So the first one, sand, which is coarse grains of rock. So when you feel that gritty feeling, it doesn't stick together. If you've been to the beach and tried to have water, if you put water in the sand, what does it do? The water just passes straight through. You can't really clump it together. It just falls apart. Sand increases space between the particles, so it allows air and water just to move on through. Ideally, the sand is used maybe more for growing trees that need that deep root, so it's going to anchor itself down deep because it needs quite a bit of roots when you compare it to a smaller plant. Oops. Sorry, guys. And then sand does not hold on to any nutrients. So it's not something that that's why you don't necessarily see like plants growing on the beach in the sand, because it is not a nutrient-rich soil particle. Silt. So this one feels soft and powdery. The particles are very small. You can see with a microscope. Water sucks up into silt. It soaks pretty well. And so these are what causes clods and crumbles when it creates that clod, but it crumbles when it's wet. So the silt particles don't really stick that great together, but it does hold us on to water and nutrients. Clay is important. Clay particles are a lot smaller and finer. It sticks together really easy. If you've used clay in like art, that that sticky feeling. It's very it can hold a shape. And soils with large amount of clay can hold the most water. It's able to hold on to the most amount of water and nutrients for plants to use. Now, is it easy to work with when there's no water involved? Absolutely not. It hardens. It's hard to manipulate, and think of it if it's going to be hard for plants to be able to grow in those areas as well. Soil profile. So that's our next word. Is we have a vertical section which shows the layers of horizons. These are the layers over time, and so horizons. Think of it like the horizon on a landscape. It's usually when you think of looking out into the horizon, you're seeing like a sunset. So there's that boundary between 2 rock layers. That is a horizon. So you can see those physical differences between each layer. So the soil profile is that collective vertical section, and the horizons, those are those layers within the profile. So here's some more pictures of a profile. So there's 3 main horizons, but there's other horizons as well. So first one, we have surface litter. That's just the regular, the litter that sits on top that's decomposing organic matter. So this is on top of what's called the A horizon. So we have surface litter. Then we have the A horizon, which is considered topsoil. This is the mixture of organic material and some rock particles. And then we have B horizon. So this is called subsoil. This contains minerals. It's leached from the topsoil, so it's things that have kind of traveled down. Has lots of clay and lots of humus. What is humus? You should have learned from the first video. And then C, horizon, is the parent material, so it's a lot of partially weathered bedrock, and then we have the bedrock that sits on the bottom. And so that's that solid rock that underneath all of the soil profile. So here's a better image of what I'm talking about. More visual, you can see the surface litter, all the plants and everything on the top. We have the A, which is a little bit darker, which is the topsoil. We have the subsoil horizon, it gets a little bit lighter. It's lighter in color because there's a lot more minerals in there. Then we have the sea horizon, and then the bedrock. So soil erosion. Erosion is when the soil is moved by water or wind. Sometimes you might see a lot on your, after it rains, you see a lot in your, a lot of erosion on your sidewalks. So that is just that loose topsoil that moves. And so that's, in order to, it also happens when lower crop yields and lower nutrients are in the soil, so because the plants can't really bind to the soil. And also the formation of gullies happens, just like this image is showing, like an indentation in the ground. So some of you might be familiar with erosion, have seen erosion. It's a big problem and something that we want to avoid. Ladies and gentlemen, that is the last slide. And so if you have any questions about soil erosion, that's pretty much all of the depth of information we're going to be getting into. And now we're going to start focusing in on plants and how they're going to use that soil, the different parts of the plant and how it works. If you have any questions, please email me. Hopefully this information is exciting and gets you excited about plants. Maybe you want to grow some plants for for fun, for a garden. But anyways, I hope you have a wonderful week. Let me know if you need anything. See you soon.